We are doing a difference of perfect squares first level. Difference means subtraction problem. Subtraction. It's a subtraction problem. And perfect squares means it's a square number. So you can look at it as 1 times 1 is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. 4 squared is 16. 25, 36, 49, 64. 9 times 9 is 81. 100. 121. 144. 169. ... Now, you are expected to have these in your tool belt, so you need to be able to recognize if you have any of these kind of numbers, okay? And I got it up to 13 squared here is 169. If you have something bigger than that, then you need a calculator. Unless you have them memorized. So either way, you have to just check if it's a perfect square number. So notice what we have here. We have a 9 and a 49. 49 right here, 9 right here. So we got our difference. Difference is our subtraction of perfect squares. And of course, x squared is x times x. So on the exponents, you need an even exponent. E-V-E-N-E-X-P-O. You need an even exponent for that to work. All right, so the trick is whenever you have this situation, you're always going to have breaking it up into a binomial, 2 terms times 2 terms. You have a plus and a minus, or a minus and a plus. It doesn't matter the order. The square root of the first one goes in the first spot. Square root of the second one goes in the second spot. So what's the square root of 9? 3. That would go in the second spot. That's in the second spot here. What's the square root of 49x squared? 7x. You just repeat it. 7x here, 7x here. Okay, and you can look at it piece by piece here, factor by factor. The square root of 49 is 7. The square root of x squared is x. Okay, so that's going to be our solution here. Parenthesis 7x plus 3 in parenthesis 7x minus 3 in parenthesis. Okay. Difference of perfect squares. So it's just kind of another way of breaking it down as a shortcut when you recognize this situation. See if the next one's any stranger. And that's what they did, is they just did the square root and showed you the square root signs. All right, let's take a look at this one. Difference of perfect squares. We have our difference sign, subtraction. Perfect squared, 25 was one of them. 144 was one of them. And then we have our x squared again. So it's going to be parenthesis set. You can do that every time. You have a plus and a minus in between, or minus and plus, doesn't matter the order. Square root of 25 is 5. What number times itself is 25? 5 times 5. What number times itself is 144? That's 12. And then we also have an x right here, 12x. 12x. And then that's going to be our solution. So each one of these is that same type of identification. You want to recognize it's a difference of perfect squares. You have to have the difference. Sometimes they'll give you a plus sign here. That is no good. It has to be a minus sign here. Okay?